In Chapter 9, we are going to be creating confidence intervals. Okay, and so in the first section, we're going to look at estimating a population proportion. A point estimate is the value of a statistic that estimates the value of the parameter. So in this case, we're looking at proportions. So if we want to find the point estimate for a population proportion, it's going to be p hat, which we've talked about previously. And that is x over n, where x is the number of individuals in the sample with a certain characteristic, and n is the sample size. So we have this poll, and 1,783 registered voters were asked whether they favor or oppose the death penalty for people convicted of murder. And the poll found that 1,123 were in favor. So we want to construct a 90% confidence interval for this proportion of registered voters nationwide who are in favor of the death penalty for persons convicted of murder. So we basically want to find an interval, a set of numbers, that we can be 90% confident that the actual proportion for the nation would lie between those two numbers. Okay, so that's what the interval is. Okay, and so if we took 100 different confidence intervals and we created them out of the samples, different samples from the same population, we would expect 90 of those intervals to contain the actual parameter. Remember that the parameter comes from the population, and we're using our point estimate, which comes from the statistic, which comes from the sample. So we would expect 90 of the intervals to contain the actual parameter, and 10 would not contain the parameter. Okay? Keep in mind that when your level of confidence is 90%, alpha is 0.10. All right, so we're going to take our point estimate and we're going to add and subtract the margin of error, and that's going to give us our interval. So as our level of confidence increases, that margin of error also increases. So if we go from being 90% sure to being 95% sure, then we're going to have a larger interval. As the size of our sample increases, the margin of error decreases. So the more members of the population that we take in the sample, the smaller that margin of error is going to get. And the more spread there is in the population, the wider the interval will be for a given level of confidence. All right, so first we need to find our p hat, which we know is x, which was 1,123, over n, which was 1,783, and we get 0.63. Well, now we need to see if we have a normal distribution. So we take n times p times 1 minus p, which we did in the previous chapter. And we see, yes, it is larger than 10, so it's a normal distribution. And so now we're going to find our margin of error. And we use this formula, and I'll show you how to find the z in class. But the square root of p times 1 minus p all over n, hopefully that looks familiar to you because we've used that formula for standard deviation in the previous chapter. Okay, so when we find that, our margin of error ends up being 0.02. So then what we need to do is take our p hat, which was 0.63, and add and subtract that 0.02. And so when we subtract it, we get 0.61, and when we add it, we get 0.65. So our interval is between 0.61 and 0.65. So we can be 90% confident that the proportion of registered voters who are in favor of the death penalty for those convicted of murder is between 0.61 and 0.65, or 61% and 65% of the population. All right, let's take a look at another example. A sociologist wanted to determine the percentage of residents of America that only speak English at home. What size sample should be obtained if she wishes her estimate to be within 3 percentage points with 90% confidence, assuming she uses the 2000 estimate obtained from the Census 2000? And that estimate was 82.4%. Okay, so let's take a look at how we can estimate a sample size, knowing what we want our confidence level to be, and what our margin of error is going to be. All right, so we're going to use a formula, and so n is our sample size, so that's going to equal your p hat, which is your point estimate when you're looking at proportions, times 1 minus p hat, times the quantity of your z-score, which again we'll talk about how to find that in class, divided by your margin of error, and then that fraction is squared, okay? And we'll round up to the next integer, because often you are going to get a decimal, and we need to make sure that we round up. All right, so we know that our E is 0.03, because in the example, in the problem, it said within 3 percentage points. So within 3% means it could be 3 above or 3 below. So that's our margin of error. We know we want a 90% confidence level, and so remember that 90% confidence means that alpha is 0.1. And so if alpha is 0.1, then when we divide that by 2, we get 0.05. So we're looking at a z sub 0.05, and that is going to be 1.645. And again, we'll look at how to find that in class. We know our p hat is 0.824. Remember, they gave us a percentage of 82.4, so we need to move the decimal point 2 places. And then we're just plugging all of those numbers into the formula, and we get 436.04, and again, we need to round that up. So the sociologist must survey at least 437 randomly selected American residents in order to be within the parameters that she set for herself. So keep in mind that if we don't have a prior estimate of P, then we are just going to use 0.25 instead of P hat times 1 minus P hat in the formula, okay? So if we don't have a prior estimate, if we don't have a P hat, then you need to use 0.25 in the beginning part of that formula.